Hello, this is Lino Tadros, and in this final video for lab number 5, we are going to try to do the whole thing with a semantic kernel agent that I will be able to create. So without further ado, let's go ahead and jump in and show you how to do that. You will notice, first of all, if I go back to the Visual Studio Code, that the preliminary code has been written for you as a cookie cutter. Let me open up under the Contoso Suite Web API. There is a folder called Agents, and this one has a C# file called Maintenance Copilot. Let's open this guy up. And we have everything actually documented in it so you can show you exactly what needs to be done. The first one, I need to add the using clauses for whatever I need for the semantic kernel itself. So let's go ahead and accomplish that. I am going to go right all the way in the beginning in here, and we will say bring in the Microsoft semantic kernel, the semantic kernel chat completion, and the semantic kernel connectors.openai. All of them are brought into that C# file. The next thing is the class itself. The public class maintenance copilot, I would like to inject the kernel for semantic kernel in it. That means I might actually start here by passing in the kernel. So just saying kernel. Notice we even have the exercise 5 task 2 to show you that to be able to use the underscore kernel or the kernel object itself and the chat history, just go ahead and uncomment these two lines and you'll be ready to go for that as well. All right, awesome. There's one more thing to do in here. If I go down to the function for chat, you will notice we have all the code here available for you will perform the chat itself. So I just need to go ahead and delete or comment out this throw not implemented exception. And the only thing left is to go through the entire code we have written for you, including the history. And I'm going to say edit, we'll say toggle the lines, and we bring in the code. So if you read this code in here, the main goal in here is you are uncommenting this code to allow the Azure OpenAI chat completion service itself to auto-invoke kernel functions defined in the database and maintenance request plugins. It also adds the incoming user message to the chat history and inserts the agent response once it replies. So you will notice the kernel get service request in here for the iChat completion, and then with the OpenAI prompt execution settings, I'm going to add a tool. This is the tool called behavior. With a one line of code in semantic kernel, I can auto invoke the kernel functions. I'm also adding everything to the history, including not only the user prompt, but also the prompt itself and the previous answers that were in the database as well. And finally, I'm going to get the results by awaiting the chat completion service, passing the history, the execution settings, and the semantic kernel object itself. And at the end, I will be bringing in the entire content from the result itself. Make sense? Not a lot of code. It's actually less than maybe 10 lines of code to be able to accomplish the chat using semantic kernel at this point. All right, we're ready for the next step, and that would be configuring the maintenance request and the database plugin itself. So let me go ahead and close this down, and we're going to move away from the agent, and now we're going to go to the plugins. In the plugins folder, we have another maintenance request plugin C# file. Let's open this up. The first thing we're going to do, like you see from the exercise 5, task 2 to do number 5, is we need to also bring in the semantic kernel to this one as well. Let me go ahead and format that correctly, and I'm going to save it up. All right. The only thing left now, if you go down a little bit in this maintenance request class, you will notice there are two functions in here. Okay, one is called create maintenance request, and the other one is called save maintenance request. And the thing they do is actually they get you the client for Cosmos DB database called Contoso Suites. It knows which container it's going to work against, and then it will create an item for the saving, for instance. And the other one for create maintenance request, it will actually get an object from the maintenance request itself, and we'll be able to prepare that for the JSON to be added as well. So remember when we did in lab 2, whenever you have functions like this that needs to be called by semantic kernel, I need to decorate these functions. So that means right before the public function in here for the create maintenance request, I need to bring in these two decorations. Let me go ahead and fix that as well. There you go. So the first one, like we did before in lab 2, the kernel function will say create maintenance request. You can call it whatever you want. It doesn't have to match exactly what's the name of the function itself. And then the description, very important. Don't think this is nothing. This is a very important piece, okay? This is how the agent will find out which tool or which plugin it needs to pull in at what time. So the description creates a new maintenance record for the hotel. Very, very important. Let me delete that empty line. I'm going to go ahead and do the same thing with the other function as well. Go down a little bit until we see where the function is, and I will end up doing the same thing. There it is. Let me format it nicely so we can read it, and I'll remove this line. So for the save one, the kernel function is called save maintenance request with underscores, and the description saves the maintenance request to the database for a hotel. All right, let's go ahead and do a control C on that. So everything is saved. You can probably tell, Lino, there is one thing that doesn't make sense. How is these functions are actually going to be able to take the kernel that I just added to the class in here? Remember when we did this for the class for the maintenance request itself? That means right before the first one, for instance, this one takes parameters like the hotel ID, the name of the hotel, the details and all that. I need to actually pass the kernel in here. So let's go ahead and add a kernel, put a comma in here. And the same thing with the save as well. I will need to do the same thing. Otherwise, we will not be able to use the injected kernel inside of there. So let me do ahead and the same thing in here. And we'll say Control S for right now. Let's go ahead and fix all of that. Huh? What is? Oh my goodness, look at that. I added to the wrong place. Let me go ahead and remove this guy from here. That is the wrong place. All right, so where is the... oh yeah, there you go. Save maintenance request. Let me go ahead and put it right there. That is the right place for it. All right, Control C to save all of that. Excellent. So now my two functions have a kernel function and have a description, which is very meaningful. And both of them, I've added the parameter of the semantic kernel object being passed to it as well. All right, we're in good shape. I have a feeling we're only missing one injection on the program.cs to be able to bring in the plugin as well. Let's go to the program.cs. Let's take a look around in here. And let's see all the singleton for the database and everything else. So let's find out maybe about the data service, maybe right after this one for the database service. I'm going to actually include the line that says kernel builder.plugins.add from type maintenance request plugin, and we bring in the maintenance copilot in here as well. Oops, no, that's not the builder services. My bad. Let me take that line out of here. That's not the correct place. I need to find out where is the kernel builder. Yeah, there you go. In here, right after the data service for this one. Okay, I'm going to come in here and we'll say kernel builder.plugins.add from type the maintenance request plugin type, and it's called the maintenance copilot. All right. So this is the right place to do it. Just find out where the adding of the singleton for the kernel, and they're all in here as well. I have an admission to make though. There is a little bit of code that has to be repeated. I know it sounds redundant, but it must, otherwise it will really not work, because the maintenance request plugin uses a dependency injection to provide a Cosmos client, right? So you must add a singleton instance of that client within your kernel service definition itself, otherwise it will not work. Do that by adding the following code right here, right up underneath this line. I'm going to come back in here. Let me go ahead, push a tab, and I'll bring it in, and we'll say Cosmos client, give it a name, equals a new connection string against the Cosmos DB, and then return the client for that as well. A lot of people ask, why do I need this code? Let me also tab that in to make it look right. There you go. Even though that code might be redundant, if you go up a little bit, you will notice there is an add singleton for the Cosmos client, but this is not enough. Whenever I do the singleton for the kernel, that has to be part of it, otherwise it will not work. So I know this is redundant code, but it is necessary, otherwise the kernel builder will not be able to use a Cosmos connection string for that as well. All right, let's go ahead and save everything, Control S. And I just want to remind you that the database service plugin was already defined in a previous exercise in lab number 2, if you remember. So just a small change needs to be completed to allow you or your agent to use it. So open up the services and go to the database services in here. Go all the way to the top of that. All right. And the small difference, if we go down a little bit, remember when we had the get all hotels in front of the get hotels, the only thing I would like you to change is the kernel function in here. I'd like to give it a name so it can match the calls coming in from the user interface. So I'm going to do this. Let me go ahead and delete that as well. Alrighty, so instead of kernel function, I'm going to say kernel function get underscore hotels, and that will make everything work from the user interface as well. We'll save all of this. All right, we're almost done. The only thing now is in the program.cs. If I open this up, remember all the routes that we worked with in here regarding the slash for the map get and the slash hotels and all of these. One of them we did not implement yet. We stopped at vectorize and vectorize search, but there is another one here called maintenance copilot chat. And that's another route, and it's actually is the last step of the exercise 5 task 2, which is the to-do number 10 in here. I do not want, of course, to throw an not implemented exception. What I would like to do is to do this, and let me go ahead and fix this as well. All right, there you go. It's not very important to C#, it's not like Python, it will still do the job. I'm going to create a variable a response, and I'm going to await the copilot.chat passing in the message being passed to it, and I'm going to return the response from the maintenance copilot chat entry or route inside of my web API. Makes sense? Let's go ahead and Control S to save this guy. All right, I am done with my API. It's all good and dandy. It's all right. The only thing left is the page in the user interface for the dashboard. So let's go back to the dashboard project. There it is. And in pages, this is the last page we're going to use for these labs, which is number 6, Copilot Chat. Let's click on that. You will notice here for send message to Copilot, we have the final number 11 of the to-do for the test number 2 and exercise 5. I'm actually leaving it empty. What you really need to do is to replace the response in here with the request. Let me, again, this is Python. You have to be very careful with the indentation and the white space. And we do a request.post, and we will go against the API endpoint itself / maintenance copilot chat, which we implemented in the program.cs of the C# code. The JSON is going to be equal to the message. And also remember, I'm doing here a 60-second timeout on the call itself. And then I'm going to be returning the text version of the response coming back in. So let me do a Control S to save all of this. You might also be interested to changing the if statement. Let's go all the way down. There will be a function in here in the function main itself. There is an if statement. There you go. React to user input. So if the prompt is coming in from the chat input, how can I help you today? There will be a lot of different possibilities. So you can actually change that code. Right now it's just an exercise for you to put whatever you want in here. I'm just going to go ahead and use this, and we'll do a Control V. And in here, let me just fix the Python code so that it doesn't give us a hard time. Oops. Yep. Yeah, welcome to Python. We'll do all of this to make sure that it is working correctly. All right. And this one and this one. Sounds good. Let me see what else. Oh, no, I have one more problem. Oh yeah, this is a with statement. So I need to take all of this good stuff in here, and we'll push tab, and we should be good to go. There you go. So now the indentation is correct. Otherwise, Python will not be happy with us. Let's go to a Control S in here as well. But you will notice that I will check the markdown for the user message. I will check the session state, chat message append. I'll put it whether it's a system prompt, which is a user prompt, or an AI answer prompt. I will end up taking all of those and put them in the history so that I can use it for subsequent questions and answers later on during the conversation as well. So remember, there are 3 different prompts that you can actually have: the system, the user, and the assistant. Okay. The stuff that you ask yourself, the stuff that is part of the system prompt itself, and stuff that the AI comes back with an answer, that's the assistant prompt as well. And they're all being added in here to the history as well. All right, everybody, I'm ready to run. So I have the 2 different PowerShell terminals available, one for the API and one for the Python dashboard. First, let's run the API itself. We'll say .NET run. Let's go for it. Wait until everything looks good, and we are ready on port number 5292, I believe. Yep, 5292. And then I'm going to open up the other one, and this is for the dashboard, for the Python dashboard. And if you remember, we did this with saying, oops, Python, in English, Python. Oh, there is a -m streamlit run index.py, and that will open it up on localhost again for 8501. Let me bring that to this monitor in here. Bring it up, maximize it. So let's give it a shot. This will be the last page all the way at the bottom for the Copilot chat in here. So let's do something fun. I'm going to come in here and we'll say a customer is reporting an issue in room 205 at the Grand Regency. The microwave is not working. So if I ask this question in here, let me see what's going to happen. is going to actually go against the OpenAI, and it's going to come back. The maintenance request for the microwave not working in room 205 at the Grand Regency has been created successfully. The maintenance team will address the issue shortly. So I might actually ask it another question. Did it get saved to the database or not? So I know it's a weird question, but you can ask the system. You can actually tell it, you remove this, I would say, did it get saved to the database? And now it's going to actually answer that question, and it will tell you the maintenance request for microwave issue in room 205 has been successfully saved to the database. And now I'm going to actually be really annoying with the LLM. I'm going to actually tell it, did you do that before I asked or after? So I'm going to run this, and it will say, I saved the maintenance request to the database after you asked. Initially, I created the request, but it wasn't saved to the database until you inquired about it. Isn't that pretty cool? The reason why it did that is because the behavior here results from the agent not having explicit instructions on how it should behave or the steps it should take during the process. It simply calls the create maintenance request, if you remember, and the kernel function, and it assumes it is done. It is unaware that the request should also be saved to the database. And of course, to fix this, you can provide the agent with a persona. It means I can go ahead and change the system persona and tell it whenever you get asked a question or actually be told about a problem in one of the rooms, automatically, after you create the object for the request, you need to save it to the database. So that is part of the system prompt that you can create. If you don't give it instructions, it will not do it by itself. You will need to actually go ahead and ask it to save it to the database. So this is something that you can change in the persona as well. If you actually want to see how to actually force this in your system prompt, that's not a problem. Let's go back here to the code and I'll show you where you will make that change as well. We'll need to open up the API code. That is the API code in here. Need to take a look where my maintenance copilot, there is the maintenance copilot. And if I go up just a little bit, remember this, the chat history here for the private chat history, call it this. I also created without any information that will be available during the request being sent. So instead of having a line like this, maybe what I can do is to remove this line and give it a little bit more forceful way of having that in the history. So let me replace this with the following. Let me come in here and do a tab in here. There you go. And what I'm going to do is actually the beginning of the chat history itself will always have that at the top, and would say you are a friendly assistant who likes to follow the rules. You will complete required steps and request approval before taking any consequential action, such as saving the request to the database. If the user doesn't provide enough information for you to complete a task, you will keep asking questions until you have enough information to complete the task. Once the request has been saved to the database, inform the users that hotel maintenance has been notified and will address the issue as soon as possible. So this is specific instructions that I need you to save whatever is coming in as far as a complaint or a problem with a room into the database. So I'm not going to leave it without any explicit instructions on how to do it. Now when I run the same exact code, and you ask the same question I asked before, let's do a Control S in here, you will get a much better way. It will not be added to the database after I ask. Immediately, as soon as I ask, this will be added to the database automatically right away. Hopefully this was useful to you to understand how to deal with semantic kernel, how to actually create an agent, and how the agent has tools that it has access to be able to send this information, how to change the persona of the system itself as a system prompt. A lot of things happen inside of this lab, but I'm hoping that you enjoyed it and you can see the power of using semantic kernel, not only as an agent, but a substitution to actually going against the OpenAI models directly for embedding, for instance. I hope you enjoyed it, and I'll see you in the final lab number 6 in the next videos. Thank you so much. Bye-bye.